Hello developers, let's start developing. My name is Veko and today we'll be taking on the 24th day of the 2023 Advent of Code. This is the penultimate day because after that we only have day 25 and then we're done with the tasks. We are not done with the solution. You can see that I'm still missing a lot of tasks. For example, I think we have everything up to 16, we're missing 17, half of 18, whole 90, we have 20, half of 21, 22 and 23 we're missing completely because I was kind of busy with some pleasant personal things that I needed to take care of. But now we're at day 24, never tell me the odds. Great name for a task. And it seems that we need to do some geometry. To be more honest, we're gonna need to do analytical geometry. What happens? We have some, let's call them moving points, hailstones actually. They're given with their position and velocity. So this is their initial position and this is their velocity. It's separated into three parameters. So that's the x, y, and z positions and x, y, and z velocities. And then we have that. So for the first task, fortunately, it says ignore everything z. And looking forward in time, so only forward in time, how many of the hailstone paths will intersect within a test area? So we have some test area and we'll need to see if two hailstone paths do intersect inside that area, but only moving forward in time. So we have things that are not really actually straight lines, but they're half of a straight line. So they're starting at point zero and then they're continuing on. So it seems that basically we have, for this task, we have something like four numbers for each thing. So we have px, py, vx, vy. And we have some kind of parametrical set that says, well, what is the current x? Well, the x is the initial x plus the velocity times the time passed. So this will be an equation that connects x and t is the time passed. And identically, we have y is py plus vy times t. So, and we want to have an intersect between 2 points, 2 lines that are displayed like this. In order to do that, I will do something else. First, I will transform this. So in this thing, I will try to solve for t. So we're gonna move px on the other hand, so it's not here. So we have this thing, and then if we divide the whole thing by vx, so we have x minus px over vx, that's equal to t. And just the same on the other side. Actually, we can do a little bit more. So x over vx minus px over vx equals to t. And we have the exact same situation on the other side. We have y over vy minus that thing. This is a constant, by the way. It's equal to t. And now we can just say, well, those two things, since the t is the same t, those two things are the same. So now I want to transform this again. So now you can see that from two equations that include x, y, and t, we are down to one equation that only includes x and y. So I would like to set this up as a canonical kind, and that is usually written in this way. So we need to determine k and we need to determine m. So that means that we actually need to solve this equation for y. So I will write it the other way around. this equals this, and then I will just take this part and move it here. And when I move it, it's gonna become a plus. So now if we take all of this and multiply by Vy, and I hope that Vy is never 0, do we have a 0 on the y? We would need to have comma 0. We don't have that. So, or an at 0. So none of the speeds are 0 in no direction. Well, that's good. Which means that we have always some kind of a curvy line. We don't have a straight line. So that means that Vy is not 0, which means we can multiply by it. So we have x times Vy divided by Vx. And I'm gonna use a plus here. And what we're gonna have, oh, I didn't need to do that. So we can just take this part first. When we multiply this part, we are only left with position of y, and then we have position of x with a minus sign. And then we have times Vy divided by Vx. And this is the format that we've been looking for, because this format and this format are identical, which means that we have that k equals Vy over Vx and m equals this. So, based on only these two values, we can calculate when two lines intersect, regardless of time. So we're excluding the time. So let's start with that. So let's take our demo input first. And once more, we do have a hidden variable, which is the size of the bounding rectangle. Anyway, we need to parse this. And note that we're going to be checking pairwise. So if we have only 5 inputs, that means that we will have to take 5 times 4 divided by 2. We will have to check 10 pairings. And our real input has a bit more data. It has 300 points, which means that we will need to check 300 times 299 divided by 2. So we will have almost 45,000 pairings. Anyway, we have our lines, and of course that I will use ArrayX for this. Let's take them all. So, well, what do we have here? And from what I've seen, all of our coordinates, initial coordinates, are positive. And why not use that? So that means that our regex will be, well, we have some numbers. Actually, we're gonna start. Oh, this was the end. So we're gonna start and then have some numbers and then have some spaces. Oh, we're gonna start and then have a comma, then some spaces, then another number with multiple digits, and then a comma, then some spaces, then yet another number with multiple characters. And now we can just say, well, I do want to extract those numbers. '19, yeah, it's colored nicely. And then we have some spaces, and then we have an at, and once more we have some spaces, and we have something that we want to take a away, and something else, and something else. So what is this? This is maybe a minus sign, and then we have some digit. It can be more than one. From what I've seen, it's up to 3, but okay, good enough. And then we have some spaces that we don't care about, and a comma, and then we have spaces and a comma here that we don't care about, and we have this thing 2 more times, and then we have an end. And it means that we missed this plus, almost. We're not passing the last one. Yeah, we're missing a plus here. And technically we're missing a plus here. So it seems that we're parsing all of these. Let's look at the big input. Are we parsing all of these? Yeah, we are. That's great. So this is a relatively convoluted regex, even though it's actually straightforward. So we can say lines.map. For each line, we're gonna do some things and then do that. Let's see. Not exact, but match. Uh, Actually, exec does the exact same thing, but in the other way, and I always prefer. To be honest, I don't know why I need prefer this one. I think it's connected with the way that exec works, that it you can find multiple matches, but in this case, I do not want to find multiple matches, so I'm insisting that it goes this way. So this is a match array. We don't need the complete match. That's the zeroth item. We actually need the groups. 1, 2, 3, 4, 5, 6. And we can literally call them px, py, oh, pz, vx, vy, vz. And the only bad thing is that all of these are actually strings. However, I will define some interfaces. Yes, that's the most used interface this so far, and we will define our interface particle. This is a Hell particle and doesn't have a PVA. So this would be position, velocity, acceleration, but let's be explicit, position, velocity. And I will say return this. So parsing px without the 10 I will get some weird values every once in a while, and I don't want to do that. So basically our input is not a string array, it's a particle array, which means that here we don't or particles. Actually, let's take the first one and let's take the second one just to see if this thing actually does anything. If I get a bunch of nuns everywhere or somewhere, it means that we messed up something. Otherwise, we're golden and we have our input parsed. Or we have some other problem. Hmm. Yeah, this thing says, well, what happens if it doesn't match? Well, then we have an invalid line. And now it knows that that method will either return a point or it will throw, which is a valid exit point as far as it's concerned. So let's see. Yeah, so everything went well. We didn't throw on any position. Seems that we have XYZ, XYZ. Let's just verify that those are the values that we had. 1930, 30, minus 2, 1, minus 2, and 20, 25, 34, minus 2, minus 2, minus 4. Okay, and we actually have 5 items, which means that we're okay. So now I will take the input and actually get line parameters for a particle. And we said, now I will just go in and copy this and see whether we are correct. Particle velocity y divided by particle velocity x, and then we have m that says position y minus, yeah, this is actually the same thing as k if I'm not mistaken, so yeah, we can actually put this here. K. Done. And I think that we're calling k the slope and the m is the intercept, yeah, of the y-axis. So we will use these terms, slope and intercept. So now I will just say input.map particle to the line parameter. So this will be params. This will be an array of slope and intercept things. So I will do a for. We will loop through those and get one thing, and loop through those and get the other things. Only not for row, it's a regular for. And we're not doing that. So now, let's see. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 comparisons, just as we said. Mm, we will need to take the time into consideration as well. Anyway, just say console log first and second. So just so we see that we're going in the right direction, we should get 10 comparisons. 4 for the first one, 3, then 2, then 1. So those are the 10 things that we want. We have the slopes, we have the things, and it seems that we have relatively nice numbers, so to say. So now we have another task that we need to solve, and there was a formula for this, but I don't know it. So if we have something like this, k1 times x plus m1, so this is a one line, and then we have another line that has its own slope and intercept, and now we need to see where these two intersect. where when they intersect, the x's are the same and the y are the same. So we need to find what is the x in that scenario. So that means we have this needs to be equal to this, which means that we need to take this to the other side and that m1 to this side. So we're taking this here and it becomes negative, and we're taking this here and it becomes negative, and we can take x in front of this, so it's x times k1 minus k2 is equal to, let's do this, minus m1 minus m2. So now if we divide by that thing, we have that x is equal to negative this divided with this. And then basically we can use either of these to calculate the y. So let's see. Intersect x is, yeah, I spent all that time to actually see this, but note that if I had no idea that I wanted to write this, this wouldn't make sense to me. So we're taking the intercepts and they are second first, and then we have the slopes first second. Yeah, a different way to do this and get rid of the minus is to say m2 minus m1. So m2 minus m1 is over that. So yeah, and we can use to get int y by just replacing it actually in the first line. So console log is over here. If we are correct, we should get some weird numbers. Something like 2/3 and so we got some results for the intersection. They're not nicely formatted. I should have formatted to some amount of strings, but it's not important. What is important is the values. So 14,333, 15,333. We have that. 11.66, 16.66. That's okay. 62, 19.4. And then we have 21.4, 11.77. And that says that's in the past. We're not checking for the past. Next we have infinity infinity, because 1 and 2 are actually parallel. And to be honest, it's not quite obvious that they are parallel. You can analyze the speeds, because don't remember that the slope is only determined by the speeds. So if x and y have a similar ratio, and it's one here and one here, they will be parallel and they never intersect. Well, we need to check that specifically, but otherwise we get minus infinity. Then we have C minus 6 minus 5. That's supposedly in the past. Minus 2, 3. That's in the past, and that's apparently also in the past. So it seems that we need to add a few more checks. So what we can do, we can see if they are parallel. How do we check that? Well, if they have the same slope. Console log, parallelize lines, that, and then continue. Let's see if we are checking that correctly. Yep, 1 and 2 are parallel. Now, next thing that we need to do is find out about the past. So now we will have the x and the y. And for example, for some first thing that occurs in the past, it's this one, 21.4 and 11.7. And we are comparing these two hailstones. And we can see that for this one, the y velocity is on the up, which means that anything that's, it will go 19, 20, 21, and so on. So means everything that's under 19, it's gonna be in the past. And we have 21. Oh, we have 11.7. So that's in the past for that line. Similarly, for the B, we have -5, which means everything that is over 20 is in the past because it goes 20, 15, 10, 5, 0, and so on. So I will actually add here one more thing. I will add a function is past that will take that will be a function that takes a y value, which is a number. And yeah, we might be able to do this, but I will say actually if the slope, and here that transfers into the slope. Does it transfer into the slope? No, no, because for the values of y, oh, it was 19, so it was going to be 14, 9, and so on. So, but we can use the slope for this, but it's simpler to just use this and these two numbers. So we can say if particle dot position dot no velocity dot y is bigger than 0, then we can have this function. We are getting y and we're gonna return whether y is bigger than particle dot position y. So if we have a positive velocity and our number is is bigger than the initial position, that's in the future. So I will just call this is future. Otherwise, if we have a negative value, we will just give this function. It's in the future. If the velocity is negative, that means we're kind of going down. So anything that's less than the initial value is actually in the future. So, okay. So now we have the y of the intercept, and we can say, actually, we will just use one by one. Console log. Not that. The point is in the past for f index. And continue. And of course we can do the same. Yeah, I wanted to have the method called isPast to avoid this exact exclamation mark, but it is what it is. It's always weird how you want to name your Boolean functions and things like that, because sometimes you actually need the other one. But let's keep it like this. Of course, we will just need to switch some signs. It's in the past for syntax. Otherwise, we have an intersection. Let's run this once more and see if we have our next calculation done right. Because if it's in the past, it doesn't worry us. So the first one, we have an intersection, we have an intersection, we have an intersection past for the first one, then we have parallel lines, Hopefully we won't have the same line with different parameters, but who knows? We have an intersection, we have a point in the past, and we have an intersection, then we have a point in the past and another that's in the past. So it seems that we are kind of correct in guessing what we want to do. Yeah, we're not checking when there's something is in the past for both of them, since if it's in the past for one of them, it's not really important whether the other one is in the past or in the future. And the last thing that's left is basically the bounding rectangle check. So we have x and y between 7 and 27. So if this and this are between 7 and 27, then we're golden. So we're going to say that we have a max of 27 and a min of 7. And that means that when we get to this, to the intersection, we just need to say if int x is bigger or equal to the minimum and it's less or equal to the maximum, and the same goes for y, then the intersection is in the box. And let's add a few spaces. Of course, we will need to count them. And then just return them. And if everything goes great, we will need to see that this one is inside and this one is inside, nothing else is inside, and we should just say 2. So we run an extremely complicated code that returns 2. Result part 1 is 2. The first intersection is in the box, the second one is in the box. Note that for the first part, we're not actually using in any sense, the magnitude of the numbers. So even though these numbers are kind of huge, we're not really using their magnitude. Except one thing, we might have a few close calls because we're working with JavaScript, and JavaScript is not really well suited for working with large numbers. Let's see what these numbers are. So I will use this trick to actually separate them. And we have 15 digits. Yeah, that's a lot. Fortunately, I think that's something like 16 until we get to 17 or 16 digits. JavaScript is quite okay to work with integers. And we actually have this value, which says this is the maximum integer where you are safe to work with it. Because if I try to add 1 to it, it will add 1, but there might be a rounding error somewhere. Yeah, somewhere around here. You saw that the last digit is definitely incorrect. It should be 1 instead of... Actually, you can even see it here, I think. If we add 1 and if we add 10, it's not the same thing. It got rounded down. So 9191 plus 10 gives you 1000. Yeah, that's incorrect. So the max saved integer, I think, has 16 digits. But I'm not sure. Anyway, this falls under that. Yeah. So this is a bit of a bigger number than the ones that we're actually working with. Yeah. Nonetheless, we do have some ways when we are multiplying. Where are we multiplying? Yeah, this can be a relatively no, this is a these are three-digit numbers from what I've seen, maybe four. So this will increase the velocity by a factor of about 10-ish. What other calculations do we have? Here we are multiplying by k, and that should be okay. And then we are subtracting, and the subtraction should be okay. And we are calculating the slope, which only depends on the velocity, so it should be correct to 3 or 4 digit decimal places, and the intercept. So I have a feeling that we will mostly be okay. Anyway, let's run our 45,000 items and see what we get. And we kind of left all the console logs in, so there will be a lot of output. So we got all of these results from 0 to that, and we're saying that this is the result. I'm not totally sure that this should be the result. We might be off by a few, and I literally mean few, but let's check it. Nope, we're golden. This is the correct answer, which means we didn't have a specific test case that tried to trip up our precision. So I guess instead of giving us this number and 1, it gave us 199999 or something like that. Upon further analysis, it doesn't seem like any hailstones will naturally collide. Oh, we want the hailstones to collide. Yeah, we want the hailstones to collide and disintegrate each other, and that means that we need to do something. You find a rock on the ground nearby. If you throw it just right, you should be able to hit every hailstone in a single throw. Yep. You can use the probably magical winds to reach any integer position you like and to propel the rock at any integer velocity. Now including the z-axis in your calculation, yeah, great. So now all of this that we did is actually much more complicated because we're working in 3 dimensions. If you throw the rock at time 0, where do you need to be so that the rock perfectly collides with every hailstone? All 300 of them. Due to the probably magical inertia, the rock won't slow or change direction when it collides with the hailstone. Uh-huh. Are these the same hailstones? Yes, they are. Initial position and its velocity. Oh. So we need to find 4 parameters. The x of the rock, the y of the rock, 6 parameters. The position of the rock and the velocity of the rock, which are both vectors of 3 components, so those are 6 numbers. Great. And it can be basically any random 6 numbers. One of the hailstone is smashed to bits 2 nanoseconds. After that, after a total of 6 nanoseconds, the nanoseconds are not important. We can just say them, call them ticks or seconds or whatever. So at time 0, the rock needs to be 24, 13, and 10. Don't add any coordinates from the rock velocity. Okay. Hmm. So now we do need to take everything into account, both the position and the velocity, and we need to have a rock. So what I'm thinking of is that we can somehow build a possible scenario of this. So not all the points are created equal, so to say. So we take a line. If we have a single line, we can basically have any line that intersects it, and we can play around with the time that we want to do that, so we can have multiple solutions for that. So given any position, I could throw a rock with some velocity so that it hits a given other line. But if we have two lines, only some lines will intersect both of them. So we will need to find the set of lines that intersect those two lines, and then maybe add another line to the mix. And then we have three lines. So for those three lines, we can say, well, we have a set of lines that intersect these lines. We have some kind of a formula that it will be an infinite number of these. But when we had this case, rock that throws a line that intersects the second and the third one, and we kind of diff them with the line that intersects the second and the third, and we diff them with the lines that intersect the first and the third, and we will get a smaller set of lines, so to say. I have no idea at the moment how to do that. And then if we add a fourth line to the mix, we have some more cases, so we can filter it even more. We can give some restrictions to our six numbers that we need to find out. So I think that in 5 or 6 or 7 lines, we will have enough restrictions in order to say that, yeah, this is the only possible solution. I have no idea how to do that at the moment, but I will need to do some thinking, and I will also need to redo this for the third dimension, and I will spare you that. So for now, I'm gonna stop. We are 1 star more than that we got last year. So last year we finished with 36 stars. I do plan to finish those videos as well, eventually. But so far in 2023, we had 37 stars, which is a great number. We will try to get them up to 50. Anyway, keep developing. If you like this video, click on those buttons, not on the bad button. And see you soon.